Okay, hello, welcome to WQE. This webinar is about electronics at the college. Electronics is a separate A-level at level 3 and is, like all A-levels, a 2-year course with exams at the end of the course. So the purpose of this webinar is to give you some idea of what the course covers, how you're going to study it, and then there's an opportunity to ask any questions at the end. Right, so electronics is the study of electronic systems, that's not really surprising, that make up small-scale electrical devices. So you can all think of many things that contain electronics. The most obvious one is a smartphone, computers, but there's all sorts of everyday devices that have got electronics in them, washing machines, and the list is endless. So I'm sure you can think of many things there that you've got around the home that contain electronics. And what we do is teach you about the types of electronics in there and also teach you to design them as well. So there's 3 elements to the course, if you like, 3 aspects of electronics. One is digital electronics, and that's the sort of electronics that you find in a computer. It's to do with logic gates and logic levels, and basically lots of ones and noughts. Analog electronics is more about signals that can have any value, an audio system, amplifiers, that kind of thing. They're all working with analog electronics, and so we teach you about dealing with conditioning signals and processing them so that you can then listen to higher quality music. The third strand is communications, and that covers the different methods of communication that utilize electronics. So that's everything from your mobile phone, radio communications, digital communications, down the internet, and so on. And again, we teach you the theory, but we're also going to be teaching you the application of these things as well. So the sort of things that you might be doing in a lesson come into 2 categories. One is practical work, and you'll be doing a lot of practical work. You'll be doing practical work in almost every lesson, and that practical work could be ranging from simply making circuits, to testing them, finding faults in circuits, and eventually when you've built up the repertoire, when you've learnt enough different types of circuits and so on, then we go on to designing circuits and designing big electronic systems. And that's what comes into the 2nd year as part of a coursework. You do a large project. On this slide, there's a couple of pictures. The one on the left is of a logic tutor board that we use for typically for early parts of the course with digital electronics, where you put logic gates into the slots and you just use wires to connect things. It makes it a lot easier to start to learn the work. On the right-hand side is a student working on what's called a breadboard, and here it's more complicated circuitry-wise in terms of constructing, but it's the sort of equipment we use when we get onto projects, and becomes more of the sort of equipment that you'd use in industry, in real life applications. For testing, we use a lot of different equipment for testing, and this is just really to show you the sort of thing we use: oscilloscopes, digital multimeters, that can be voltmeters, ammeters, ohm meters, all sorts uses for those. And we've got lots of apparatus, lots and lots of equipment. Being a big college and having a lot of students doing electronics, we are able to source and buy a lot of apparatus and high quality new apparatus that we can refresh and renew. And this means that you can be doing the practical work on your own, developing circuits, testing your own circuits, rather than working in pairs or a group. So the other aspect of the course is the theory. You obviously need to understand the theory that underpins the practical work. So there's the theory of designing circuits, and so you'll be having to work with circuit diagrams like this. This is a digital electronic circuit of logic gates. Don't expect you to understand it now, but it gives you an idea of the sort of circuit diagrams you might have to deal with. And these circuit diagrams in skill development, you'll be learning to analyze, to work out what that circuit's doing, but also to design circuits to that level of circuitry. We also do circuit analysis, and this is just an example of a circuit that you might analyze using the maths on the right-hand side there. So the course does have a mathematical element to it, but that maths follows on from GCSE. There's nothing in there that you wouldn't be able to access with the appropriate maths at GCSE. So a few questions that people normally ask, and one is, what courses go with electronics? And there's some obvious ones like computer science, ICT, physics, obviously, because the electronics has very strong links with the electrical part of physics. Design, which is all about designing, obviously, and in electronics there is a large element of design and creativity in applying the electronics to solve everyday problems. Maths, of course, goes well as well with electronics because there is quite a mathematical element to the electronics. In terms of career options, electronics is a form of engineering. It's one of the disciplines of engineering, but electronics in itself, even if you didn't go on to study electronic engineering later on, gives you a really good understanding of the engineering approach that you'll be applying in other engineering disciplines. The idea that you're learning, the way I put it, you're learning what something does, not necessarily how it does it, not how it works, but what it's doing. And then you use that in your design to create a full electronic system. Other careers that it goes well with, lead you into, are things like computing and IT. Computing, IT are the, well, computing is the software side of it, and electronics fits very well with that being the hardware side of the machine. And for IT, obviously, some of the time there, one aspect of that is looking at hardware, and the electronics fits with that. Design, as I've said before, design can incorporate electronics in all sorts of ways. And you can think of many systems where you've got a design, but there's some element of the electronics in it. We had a student a few years ago who did a design project, and he incorporated his electronics in there to make an electronic sort of chest of drawers system. Science, a lot of science research has requires the application of electronics in terms of experimental work, in terms of monitoring and analysing. And business, a lot of businesses are impacted by electronics, and having an understanding of the electronics can, in some cases, help with understanding the business. And we have students who go on to all these areas, who've studied A-level electronics with us. Although I would say the vast majority go into engineering or computing and IT. That seems to be the main destination of students. So the question a lot of students ask is, do I need to have done electronics at GCSE? And the answer is no, definitely not. You don't have to have done any electronics before. And almost all of our students, about 90% of this year's students haven't done GCSE electronics. And we assume that when we start teaching the course, we start from scratch. We teach you as if you know nothing about electronics, and certainly just from the physics GCSE, you'll know more than nothing. So that's no problem at all. So whatever you do, if you're considering doing electronics at A-level, don't think that you need to have GCSE electronics. Don't think you'll be disadvantaged without it, because almost all the students who do electronics at A-level have never studied it before. So the last question, which I think is really quite important, is what qualifications do you need to enroll on the electronics A-level course? And the grades are there quite clearly. You need a double 5 in combined science, or a 5 in GCSE physics, and you need a 5 in GCSE maths. And then for English, you need the basic college requirement for English, which is a 4. So that gives a bit of flexibility there. Okay. So now it's over to you. Has anyone got any questions? Megan, have we got any questions there?
We've had one so far.
Okay.
Which is from Mawish, and it is, will this course be good for engineers?
Okay.
So you did touch on this bit.
I have kind of answered that, haven't I? Yes, it's absolutely ideal. And admissions officers and engineering universities, engineering departments, they really like to see students who've done electronics, because it is engineering. You're most likely, if you want to go on to do engineering, be doing physics and maths. Electronics goes really well as a combination of those 3 subjects. But they will really like to see the electronics in there. The physics is, as you know, because you'll have done it at GCSE, the physics is very much theoretical, very much down to the detail of what's going on with things and why things do what they do. Electronics is about what they do and how we can use them. And that is more of an engineering approach. Okay, have we got any other questions?
Yep, another one's just come through, and it is, would we be making anything other than circuits? Also, will there be a project at the end?
Okay, yeah, really good question. First of all, there's 2 projects that you do, both in the second year. One is using microcontrollers, and this is a really interesting one, because in terms of making will we just be making circuits? And I'll come to that in a minute. The microcontroller is a small integrated circuit that you'll be learning to program. It's not a computer, but it is a programmable electronic component. And we teach you how to program it. It's very much like the gold square on your credit card. Although I'm not going to teach you how to program that and get lots of money in your bank account. And we teach you to program it, and you do a project around that using the microcontroller to solve an electronic problem. There's another project in the second year, which is a larger project where you can do anything you like, and you can use whatever electronics you've learned, whether it's a microcontroller or general circuitry, to make that project. In terms of, will you just be making circuits? You won't. I've already described the microcontroller, where you're learning about programming a piece of electronics. But you're also not just making circuits, you're testing circuits, you're using circuits to get results that you can analyze so you can understand what the circuit's doing. And you're doing evaluation of circuits as well. So there's a lot more work, but effectively, electronics is circuits, electronic circuits, but what you can do with them is almost limitless. And that's what we're trying to get across to you. And the degree of imagination there is there as well to be creative about how you're going to use the electronics.
Okay.
Okay, any other questions?
There's a few coming in now. So will we program different electronics and how is it done?
When will you program? But it's done in the second year, normally the start of the second year. And we first of all teach you how to program it. It's done using a specific language for this microcontroller called ASMIDE. I doubt you'll have heard of it at all, but you do that through a laptop. So each student will have a laptop where they do the programming into the laptop. We then have a bit of software that converts your program into logic ones and logic noughts and downloads those logic one and logic noughts onto the microcontroller, which then carries out your program by interfacing with light sensors, temperature sensors. It runs motors, lights. It can control various things. And that's what these microcontrollers are for. They're for a small device to control various things.
Okay. How much of the coursework is exam-based? Sorry, how much of the course is exam-based and how much is coursework?
Really good question. Yes. I'll put that in my frequently asked questions next year. The course is 20% coursework, and that's made up of those 2 bits of coursework that I've already mentioned. And the rest, 80%, is on 2 written exams that are sat in the summer of the second year.
Okay. How do you see the future of electronics growth in this country to compete with countries like China?
Whoa, no, that's a really interesting question. I like that. How do I see? This country has is a key development location for components, integrated circuits for Apple phones, iPhones, and there's a lot of other industry that uses electronics around. There's the country's got a big space industry, and a lot of that is electronics based, as you'd expect. And that space industry, not so much about rockets going to the moon or Mars. It's more about satellites and communications and that side of space. But there is a lot of electronics industry in this country. It's a good employer, and there is a shortage. There's always a shortage of good electronic engineers. So yeah, I see a strong future in this country. There's also, COVID aside, opportunities for study and employment in other parts of the world. And that a subject like electronics, really opens that up.
Okay. Next question. I'm really interested in robotics. Is it possible that this could be done for the project?
That's an interesting one. Robotics, it has a lot of electronics in it, but it's also got movement control systems, pneumatic systems, and so on, sort of which are more mechanical engineering. So we don't or we haven't had students doing projects with robots. That's not to say it wouldn't be possible. You know, you'd have to, when we come to doing a project, you start off, come in with a proposal of what you're going to do, and we can discuss that and look at the feasibility of it, by all means. But it isn't, robotics itself isn't an integral part of the course because it's a mixed engineering sort of topic area.
Okay. Would we need to learn programmable language?
There's a programming language for the microcontroller. It's not a difficult, complex language, and I think all students get the hang of it. You can, the skill is then in using that language in different ways to make your program more complex, more sophisticated. But it's very accessible programming. We teach that to you in a couple of weeks. Well, in less than 2 weeks, you'll be writing your own programs. It's quite straightforward. And it is not, well, how can I put it? It's not a complex thing. It's using language, words. You have instructions like go to and things like that. So you're using words rather than code.
Okay.
Yep.
And then following from that one, what other programming language could be used with electronics, e.g. Java, Python?
Okay. To be honest, I don't know a lot about Java or Python. I'm not a computer programmer. The program we do is very light, and it's not making the level of programs that you do in computer science. At university level, at degree level, I could easily imagine either of those programming languages being used in electronics, but certainly what we do doesn't involve anything as complex than that. And if you are doing computer science, then you'll find the programming we do in electronics just a stroll through. It'd be very easy.
Okay, and this is the last question, I believe. So, is electronics a more sought after subject in universities, like the core subjects such as physics for engineering?
Right, you'd need to, it's a good question. You need to have a look at the UCAS website to have a look at what the course requirements are for different courses, because it does vary. For engineering, a lot of universities say that I think all of them will say you need maths. You can get on an engineering degree without maths. They'll teach you the maths on the course. That would be a foundation course. But you'd need maths, and generally they say you need physics. Electronics is a good third. I would say that the maths and the physics are the key core subjects. They can get you onto any engineering course, absolutely. The electronics is a course that will it will give you a really good engineering experience, get you in the mindset for engineering, in terms of problem solving, in terms of the approach, in terms of the design. But that will put you ahead of other students. That will give you an advantage because you know what you're doing. You'll be more attractive to universities and so on. On its own, it wouldn't get you onto a degree course. But in combination, it works really well.
Okay, great.
Okay.
So, one last question just come through. Last one. On average, how many students get an A star?
On average, how many students get an A star? percentage of A stars varies year to year. We normally get somewhere between 3 and in exceptional years, sort of 8 or 9. But that number in itself doesn't mean anything, because it depends how many students there are in a year group. And we tend to have anything from 30 to, we have had 70 students doing A-level electronics. So the numbers vary. A good student who works hard will get an A star, yeah. Yeah, I don't think I could say any more.
Fair enough. Okay, so that's it for the questions. I just want to add, if anyone does have any more, they think of any at a later date, you can email them to admissions@wqe.ac.uk, and then we will forward them on to David Lomar so that he can answer them for you, if that's okay with you, David.
Yeah, that's fine, yes.
Yeah, so it's admissions@wqe.ac.uk if you have any further questions. So
okay.
That's it.
Well, I hope that's been helpful for you all. Thank you very much for your questions. And as Megan says, if you've got any more, just send them in.
Yeah. Thank you all for watching, and yeah, see you soon.
Okay.
Thank you.
Look forward to seeing you in August. Bye.
Bye.